Okay, here we go. It's page 2, 4, 5, 6, 7. So not that many. So 1, create a scale for the numbered line in order to plot the points. So you can simply create a number line. Okay, and let's see. We can make -3, -2, -1, 0, 2, 3, 4, 5, 6, and that should be a 3. So graph each point and its opposite on the number line. Okay, so -2. The opposite of -2 is 2. Okay, how do I know these two are opposite each other? Because they're both two spaces away from 0. And no, they're not, because I forgot to write the 1. So let me try to do this again. Right, let's try it again. Okay, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. So first one was -2. Okay, it says graph each point and its opposite. The opposite of -2 is 2. I don't know, these two are opposite. They're both two spaces away from 0. 4 will be here, and the opposite of 4 is -4, and that I didn't draw, but you can put it right here. Okay, -4. They're both 4 spaces away from 0. And then 6. Well, it would be this 6 with its opposite, which is -6, somewhere around here. They're both 6 spaces away from 0. That's why I know they're opposite each other. Callers use a vertical line graph to graph the points. Okay, so vertical line drop is number line. Okay, is one that goes like this instead of horizontal. This one's going to go up and down. 0, 1, 2, 3, 4. So that's 3, and this is 4. And -1, -2, and we want -4. You notice that -4 is closer to 0 than -2. He's not sure about his diagram. Use what you know about vertical number line to determine if Collins made a mistake or not. Well, there's no way -4, which is right here, is closer to 0 than -2 is closer to 0. Okay, the distance between 0 and -2 is 2, and the distance between 0 and -4 is 4. Okay, so we're talking about absolute values, right? The distance a number is away from 0. So I don't know what Collins is looking at, but definitely not the right thing. Create a scale in order to graph the numbers -2, 12 through 12 on the number line. What does each tick mark represent? Each tick mark, well, geez. So here's 0, and here's, all right, I'm not going to do all the way to 12, okay? So that's 12. This is -12. Okay, so -11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each marker represents 1 unit. Okay, although mine are not evenly spaced out, they represent 1 equal unit of measurement between each of them. Okay, choose an integer between -5. Okay, so all right, let's create here. And this one, all of you is going to have different answers. That's okay. That's 0, -1, 2, 3, 4, 5, and you were to choose anything from -5 to -10. Okay, since I'm lazy, I'm going to choose -5. And let's call that R. Okay, that's what he says. What is the opposite of R? Well, the opposite of R would be 1, 2, 3, 4, 5, which is 5, +5. So the opposite of -5 would be 5, and they want us to call this Q. Let's call it Q. All right. State a positive integer greater than Q. Well, something greater than Q, an integer, 6, and we'll call that T. State a negative integer greater than R. So something that is negative but greater than -5. Well, here's -4, and that's greater than R, and we'll call that S. State a negative integer less than R. Okay, so something that's smaller than -5 would be -6, and we'll call that U. And state an integer between R and Q, something between R and Q. And in integers, you have a lot of choices. And let's just pick 1 over here. And we'll call that V. Okay? Okay. 5. Well, the opposite of a positive number is always, sometimes, will never be opposite. The opposite of a positive number will always be a negative number. Okay? The opposite of a positive number. So, if you don't know the answer to that, just make a number line. That's 0. Pick any number. Pick 1. What's the opposite of 1? Negative 1. Pick another number right here. Let's make this 100. Positive 100. The opposite of 100 would be negative 100 on this side. So, for any positive number, its opposite will always be negative. Okay? Well, the opposite of 0 is always be or sometimes be never 0. Opposite of 0, it's 0 because 0 spaces away from 0. In order to be its opposite, you have to be the same distance away, either from the negative side or the positive side. So in this case, 0 is just 0, always 0. 7. Will the opposite of a number always, sometimes, or never be greater than the number itself? Explain. Provided an example, the opposite of a number. So let's take the opposite of negative 5. That opposite would be 5. So if a number is negative, its opposite will be greater than the original number, which is 5. 5 is greater than negative 5. That's true. What if you take a positive number? Let's take 6. The opposite of 6 is negative 6. Is negative 6 greater than 6? No, it's not. So, not all the times when you take the opposite will it be greater than the number you started with. So, if you start with a negative number, take its opposite, that's going to result in a number greater. But if you start with a positive number and you take its opposite, you're going to end up with a negative number, which is going to be less. Okay? Now let's move on to page 4. Page 4. Ooh, okay. So, there's a bunch of things going on here. Okay? And we want to describe an integer for each scenario. Okay? So, it's not that difficult. And I just got to make sure I can. Alright, so write each individual description below as an integer. Model the integer and number line using the appropriate scale. So, open a bank account. Opening a bank account, he deposited $0, so it's going to be just 0. 0. Okay. Number line model. Right, so on number line, I would just put 0 there. Open. I'll call this open bank account. So you open the bank account with 0. Make a deposit of 150. The integer would be plus 150. Okay, obviously, if you deposit, it's plus 150. That's what you can write. And to open, from 0 you go all the way to 150. So that's where you are right now. There's an increase on the positive side. Credit an account for 150. So credit, okay, means that somebody gave you another 150. So for 150, you gained another 150, so you're now at 300. So that's again plus 150. Okay, and then from 300, which is where you are, how much money you have, you're making another deposit for $25. So from 300, you're depositing 25, and your account just grew again to 325. So that's described as positive 25. And a bank charge. So there's a bank charge of $5. Well, if you're here at 325, let me just continue that. 325 and the bank charge of $5, that means you just lost $5. So you're going back 5 spaces, or you're now at 320. So the description would be negative 5. And finally, you have a withdrawal of 35. If you withdraw, you're taking money away. So from 320 minus 35, you would go to 285. And the withdrawal of 35 is represented by negative 35. Okay. Let's see where we are. Okay, so how hot, how cold, temperatures commonly, blah, 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 blah. The boiling point of water. Where's 100 Celsius located on the thermometer to the right? Okay, you have the thermometer here is divided into, I hope you noticed that it's divided into two sides. Okay, one is in Fahrenheit and one is in Celsius. So numbers are labeled on both sides. So 100 Fahrenheit. Okay, and I'm just gonna make sure that I see. I can't see it. Okay, so what we do know is that here 0, okay, 0 is in the Celsius and 32 is on the Fahrenheit side. So 100 Celsius would be about here. Okay. On the vertical number line, describe the position of the integer that represents what? 100 Celsius. The position, all right, the position of 100 Celsius, that is 100 units above 0. Okay. Write each temperature as an integer. The temperature shown to the right in Fahrenheit. Excuse me, what does that mean? Write the temperature shown to the right in Celsius. Okay, I have no idea what that means. Write each temperature as an integer. The temperature shown to the right in Fahrenheit. The temperature shown to the right in Celsius. To the right of what? Okay, not making any sense. Freezing point of water in Celsius. In Celsius, the freezing point is 0 and Fahrenheit is 32. If somebody tells your body temperature is 98.6 Fahrenheit, what scale are they using? How do you know? Well, 98.6 must be in Fahrenheit. Okay, because in Celsius, that would be like about 30 something, 36, 37. Okay. Does the temperature 0 degrees mean that the same thing on both scales? No, it does not. Okay, 0 Celsius means 32 in Fahrenheit, and 0 Fahrenheit is much colder weather in Celsius. Okay. Wish I could get this page. Alright, I particularly didn't like these questions. 6. Write each loss under the appropriate column, positive, negative number, well, depending on the situation. So, let's see, plus, minus. Okay, something's happening. Come on. Alright, let's try again. No. Let's try again. Positive, negative. Okay, so gain, I'll draw a line. You can call this gain. Loss would be negative. S. Deposit would be here. Credit would also be here. A debit, it's over on this side. A charge would be this side. Below 0 would be this side. Withdraw would be here, because you're losing money when you take money from your account. And O would also be a negative. And we have one more that I can't see. And received. O and received. And received definitely is something that is positive. Okay? And that these two are the first two words. Okay, of your code. So let's continue. Write an integer to represent each of the following situations. A company loses. Well, obviously, if it loses, it's negative 345,000. You earned, you made, so that's 25. You owe, or Jacob owes, would be negative 5. Okay. The temperature at the sun's surface, about 5,600 Celsius. Well, it's pretty hot, so that's above, positive. Temperature outside is 4 degrees below, negative 4. Okay. And then football player lost 10 yards. To lose means negative. And describe a situation that can be modeled by the integer negative 15. Explain what 0 represents in the situation. Well, a situation that can be modeled. It is negative 15 Fahrenheit. Okay, so you can write a temperature, which we had not too long ago. Temperature yesterday was negative 15 Fahrenheit. Explain what 0 represents in this situation. Well, in this situation, 0 represents, you know what, instead of Fahrenheit, I'm going to use Celsius. Negative 15 Celsius. Okay, and 0 represents the temperature in Celsius when water starts freezing. So, okay. Or, let's see another example. I lost $15. And 0 is alright. And if I was at 0, it would mean that I would be even. Okay. Next one, and I think it's the last page. Okay, this was easy today. Represent each situation as an integer space provided. Again, gain plus 56. A fee minus 250. That's something that they charge you, so you're going to lose 250. Minus 32 because you below 0. Another minus 56 because you lost. The freezing point of water in Celsius is 0. And a 12,500 deposit is something that you gained. Positive. For questions 2 and 5, use the thermometer to the right. Each sentence stated incorrectly. Rewrite the sentence to correctly describe each situation. Temperature is negative 10 degrees Fahrenheit below 0. Temperature is negative 22 degrees Celsius below 0. Each sentence is stated incorrectly. Rewrite the sentence to correctly describe each situation. I'm not under. Wait, my God. Let's skip number 2. Let's go to number 3 right now. I'm not really understanding why 2 is incorrect. All right, 3. Mark the integer on the thermometer that corresponds to the given temperature given. That's not that hard to do. So 70 would be around here. 12 Celsius would be on the other side. Okay, just make sure although I can't write on it. So 12 Celsius would be around here, where my little icon here, the arrow is. 110 Fahrenheit would be on this side, just about there. And negative 4 Celsius would be on the right side, and 0, and it would be about here. Okay. The boiling point of water is 212 Fahrenheit. Can this thermometer be used to record the temperature of a boiling pot of water? Well, let's look for 212 Fahrenheit. Well, it doesn't go that high. Okay, 12 Fahrenheit would be about here. Okay, and yeah, it wouldn't work. Okay, because it's not, the scale doesn't go that far up. Okay, Kalon shaded the temperature to represent a temperature of 20 degrees below 0 Celsius as shown in the diagram. Okay, so 20 degrees below 0 Celsius as shown in the diagram. No, he didn't. Shaded a temperature of 20 degrees below 0 Celsius. 20 degrees below Celsius would be around here, where the arrow is. I don't know what they're talking about. Is she correct? Why or not? If necessary, describe how you... Okay. Obviously, what Kaylin did, she labeled 20 degrees below 0 on the Fahrenheit side. Okay, that's what she's doing here. Okay, because 20 degrees below 0 on the Celsius side would have been where the arrow is right there. Okay, so easy, very easy today, very simple. Let me just go back to 2 for a couple of seconds and just see if I can figure it out. Each sentence is stated incorrectly. Rewrite the sentence to correctly describe each situation. Temperature is negative 10 degrees Fahrenheit below 0. Temperature is negative 22 degrees Celsius below 0. What am I missing here? I guess they mean what the blue markers, what the temperature is now. So in Fahrenheit it's actually negative 20, I'm assuming. And then in Celsius, the temperature right now is about negative 29 on this side. Okay, if we're looking at the thermometer and we're reading the temperature on the Fahrenheit side is negative 20, and on the Celsius side is negative 29 Celsius. Okay, all right, and the second word, third word I should say, that completes the statement would be I just made that up. Okay, so that was the previous words, 2 words, makes your statement for the day.